So then we're going to take a look at the behavior at zeros. So we're looking at our x-intercepts and seeing is there any kind of pattern that we can tell to see kind of how the graph is doing. Because the object of looking at these in this section is to graph our polynomials. So here we have a polynomial f of x equals negative x to the 6th minus x to the 5th plus 4x to the 4th plus 2x cubed minus 5x squared minus x plus 2. Alright, and so what we want to do, what you can do is if you would find the zeros, and we could do that by listing the possibles and then run through synthetic division and finding the zeros, and it ends up to be factored. So you could factor this to negative on the outside, right, because it's a negative x to the 6th, so our a would be negative. So that's going to make this face down, as well as it's an even number, so we know it's kind of going to face down and on one end and kind of look like, because it's to the 6th, so it should look something probably in that general kind of shape as that. But it's going to do some different things at these x-intercepts here. So if we found those x-intercepts and we were able to factor it, it would factor to negative times the quantity x plus 2 and x plus 1 quantity squared and x minus 1 cubed. And we kind of talked about what are the zeros, right, with multiplicity. Right, so that means that minus 2 would be a 0, minus 1 would be a 0 with multiplicity of 2, and positive 1 would be a 0 with multiplicity 3. And so those multiplicities kind of tell us something that's going to happen at those x-intercepts. Okay, and there's kind of three different scenarios with multiplicity when we're looking at our zeros. Is if we have a multiplicity of just 1, right, that just means we have one answer, negative 2. What's going to happen is on our graph, on our x-intercept, so let these be our x-axis here. So if we have a 0 right here, say c, just let it be any random number, okay? C, what's going to happen is when I have a multiplicity of 1, so you could let c equal negative 2 for this example, it's just going to either just go straight through like that, just cross it, or it's going to cross, so it's going to cross increasing, or it's going to cross decreasing, one of the two. That's if there's a multiplicity of 1. If there's a multiplicity of 2, like x equals negative 1 here, so if this is our c was equal to negative 1, here when we have the multiplicity of 2, what's going to happen is when it comes down to that 0, when it hits that x-axis, it's just going to bounce right back. Or it could be coming from increasing side, so it could be increasing and it's going to bounce right back down. So that's a multiplicity of 2 or any even multiplicity. Where here it's a multiplicity of 1, and usually don't even say multiplicity of 1, we just say it just has 1 0, right? So anytime you have an even multiplicity, it's going to bounce right back off that x-axis there. Now an odd multiplicity, so we have an odd multiplicity at 1, so this is our 1. What it's going to do is it's going to kind of do like what a cubic does, how a cubic kind of flows in and out like that. That's how that's going to do. With the multiplicity of 1, it kind of goes straight through. It's a line, where any odd multiplicity is going to do kind of like a cubic does, where it kind of curves the way through. Or it could increase by increasing, or it could curve by decreasing. That's kind of ugly curve there. By decreasing through that 0. So that's kind of how the behavior at the zeros, at our x-intercepts. Multiplicity of 1, it's a straight line through, either increasing or decreasing. Even multiplicity, it's going to bounce right back up. And then an odd one is kind of going to curve its way through that 0. So that's kind of it for behavior at zeros. You definitely use these as you go into calculus when you're trying to find what the graph actually looks like and how it behaves. Just by looking at the equation, you can start to pick that kind of stuff up.